Recording in progress.
All right, everybody, let's get started. This is, let's see, make sure I'm all the way out. We're working on right now, this is lecture content for section 2.3. This is on limit laws and things like squeeze theorem. This will be video A. I'm going to break this into parts. There's a lot to go over here. So, previously we've seen a couple limit rules in another section. We've done limit as, let's call this limit law A. Limit as x goes to A of x equals A. And we previously saw limit as x goes to A of C equals C. I'm pretty sure that was listed in the last section. Examples of this include doing something like this. The limit as x approaches 8 of x equals 8. Limit as x approaches -2 of 4 equals 4. Those are the two base limit laws. Then we have a lot of laws that work on combining two functions. That's not the two I'm looking for. I'm looking for that two. So let's say that for the following, the limit as x approaches A, that isn't even how I do my L, it's always lowercase. F of x, let's call that L. And we're going to do limit as x approaches A of g of x, and we're going to call that M. It's some value. These are just numbers. L and M are numbers. So our next limit law has to do when we add these. If we're doing the sum of the two functions, limit as x approaches A of f of x plus g of x. We can split this into two limits. Limit as x approaches A of f of x plus limit as x approaches A of g of x. And the first one is L and the second one is M. So we just end up with the sum. And these are going to be two numbers, so it's going to make a third value when you add them together. The minus one isn't any different, but I'll make it a different line if it helps people. We have f of x minus g of x. This is the limit as x approaches A of f of x. Minus the limit as x approaches A of g of x. I guess I didn't need all these things right here. That was extra. Which equals the first limit here. This is L and this is M. So we have L minus M. Then we have the limit law when if there's a constant times it. So limit of, as x approaches A, if there's a constant times f of x, we can actually just pull the constant out. And that ends up in the limit there is L from up above. Move this one down a little bit because it looks like it's slightly different than the other ones. Then we have the product when we multiply them. Limit as x approaches A, if we're going to do f of x times g of x. This is the limit as x approaches A of f of x times the limit as x approaches a, that's not an a, of g of x, and that ends up being L times m. Remember, let me do that where I got those up above. And then we have division, a quotient rule. Quotient. Limit as x approaches a of f of x over g of x. Here we can apply them to each one individually. And the top is L and the bottom is M. And this is true or valid if M does not equal 0. We'll look at a case in a later video in 2.3 on when M equals 0. We got a few more limit laws. We'll bust some examples on them and work with them. Limit as x approaches a. If we have some function f of x to the n power, we can actually take the exponent outside. Do limit as x approaches a of f of x. Do that limit first, then do the exponent. I'm going to use a capital N. And now the limit there is L, so we have L to the N. This is good when N is greater than 0 and N is a positive integer. I guess I don't need the greater than 0 when I'm going to add that here. N is a positive integer. Like 1, 2, 3, 4, dot, dot, dot. One more limit law, and it's related to fractional exponents when we have a root. Limit as x approaches a of the nth root of f of x. This does the same thing as the exponent thing. We pull it on the outside. We do the limit as x approaches a of f of x. And I didn't give myself room to do the square root thing, so put the square root in now. Which equals the nth root of L. And this works. This is, you might learn a new notation right now. We're going to say this is true. We have an upside down A. Upside down A in mathematics means for all. So this is true for all L if N is odd. And it's true for L greater, it works for L is greater than or equal to 0 if N is even. Like the fourth root of -1, this is imaginary. And so we don't want the inside to be negative. It's got to be greater than or equal to 0. Okay? So let's take a look at a couple examples. Example 1, we're going to do limit as x approaches 4. Well, let's go -4 of 3x minus 2. I'm going to take this slowly, break it into parts. You're going to end up learning stuff that makes you go much quicker. This is the limit as x approaches -4 of 3x minus the limit as x approaches -4 of 2. And then I can take the 3 out because the 3 is a constant. And that should say -4. But we saw we can apply the first two limits here, limit laws here. When you do a limit of x, it just goes to the x. So this is 3 times -4. And this one is a constant, so we just do the constant. And that ends up being -12 minus 2 is -14. Okay. Next one's a little bit more of a pain in the ass, but we're going to do it, and then we'll learn a faster way in the next video. Limit as x approaches -1. We're going to do x squared plus 3x plus 1 over x cubed plus 2. So here we can apply the limit to everything individually. X to the going to -1 of x squared plus limit as x goes to -1 of 3x plus limit as x goes to -1 of 1. Again, we'll learn something faster in a second, but the faster thing works because this step is true. Limit as x approaches -1 of x cubed plus limit as x approaches -1 of 2. Now I'm going to apply all the individual rules. When we have a square, we can move the square on the outside. I can say limit as x approaches -1 of x squared. That's this is this piece right here. And then I've got limit, or I'm going to do 3 times limit as x approaches -1 of x. We've seen that before, so I'm not going to highlight that one. And we've got limit as x approaches -1 of 1. And on bottom, we have, I can pull the cube out. Limit as x approaches -1 of x cubed. That's this one here becoming this one here. And I have limit as x approaches -1 of 2. All right, so all the ones that are x, we just plug in the value of the limit. So this is -1, and that's getting squared. And then I have 3, and then that limit's -1. This is a constant, so it's just the constant. This is -1, and then we've got a cube, and this is 2 because it's a constant. So this is -1 squared is 1, and then that is -3, that's +1. -1 cubed is -1. So this ends up being -1 on top and 1 on bottom, which is just -1. Okay. I'm going to pause the video real quick.